studies have added evidence to the debate, which I can touch upon, but I'll touch upon. The first one is probably the most famous paper on limits to, or lack of limits to a world record, published by Whip and Ward, Brian Whip and Sue Ward, who very sensationally got an article published in Nature predicting that women would run faster than men, and interestingly, that women would be running marathons faster than men by the year 1998, published in 1992. But of course, as you all know, Paula Radcliffe's world record has stood for many years, and Kimito broke the world record, the mile record, not that many years ago, 2 years ago. So this prediction has not come to pass. How the paper was presented in Nature, and draw your attention to the picture, and they said, will women soon outrun men? Question mark. And the whole story was based about some regression lines, where they had the men's regression lines going here. This is the 200 metres, 800 metres, going down to the marathon. Regression lines going up so that the speed's increasing, and then the women's regression lines were doing this, much steeper. And so they thought that by allowing us to extrapolate, and this is the big sensational one here, where women would run faster than men before the turn of the millennium, which of course never happened. So that's the basis behind the ideas of Whip and Ward. Quite clearly, Whip and Ward are assuming that there is considerable reserve. They're on the second of the two camps. Those that have got this concept of reaching a plateau, and obviously Whip and Ward were on the other camp, saying that there's considerable reserve, that they will carry on in a linear fashion, which is a bit questionable. A second article by Tatum, published much more recently, didn't follow quite the same rationale, but the same idea, and they said that women would be running faster than men, and this was focusing on the 100 metres, that women would be running faster than men by the year 2156. I hope I'm there to find out whether it's true. So that's what they said. Once again, a sensational headline that momentous sprint in 2156. And once again, they use linear regression lines. Here's now the times rather than the speeds. And the women's time obviously taking longer, so the red line is the women's line, and sure enough, they're going to overtake the men in this momentous year. So they said, but draw your attention to the fact that this was published in one of our most prestigious journals that have ever become, is really famous for publishing quality research. So I just cannot believe what kind of review process allowed both the Whip and the Ward article or this Tatum article to get published. It must have been sensational journalism, that's all. So obviously we've got to be a little bit cautious. Problems with the data collection. It could be the fact that there were some errors in data collection and that could cause problems. A second problem could be the fact that we've got systematic doping that could distort those regression lines. So there's obviously possible problems associated with it. But the biggest problem, as far as I'm concerned, and as far as good scientists, hopefully most of you in this room, are that they've used linear regression lines that could almost certainly be the greatest source of the error involved, linear regression. Because both those articles, one of them has got to be wrong. The Webb and Ward article used speeds, and the Tatum et al. Article used times. And if one's correct, the other one has to be incorrect. So if the times are correct, speeds must be wrong. If the speeds are correct, the times must be wrong. And I'll demonstrate that why that's the case as follows, which will appeal to most of your almost O-level or GCSE level standard mathematics, statistics. No, both can't be correct because if, for instance, speed is a linear regression line, then we know that speed is distance over time. So if time and speed are related by time equals distance over speed, or speed is distance over time, so that equation is always true, so that if speed is a linear function of the years that are going up, so the speed is going up in a straight line, then the time term must be covered by this hyperbolic function, which is distance divided by the linear term, or something divided by a term that's not linear, that is linear, must become a curve. So both cannot be true. One or the other could be possibly true. Okay. Furthermore, the conflicting limits to which humans can run, no limits to the speed at which people can run or the times that people can achieve. And the one that's probably the most problematic, of course, is the Tatum article, where they've got this negative decline. So it's going to suggest that at some stage in the future, people, if that linear decline was true, at some time in the future, people will be running negative times. The science is obviously fundamentally flawed. So, what's the purpose of the discussion that I've drawn your attention to? Well, the purpose of the article is that the lines, either line, but it doesn't really matter which, the lines must be questionable, and perhaps we can fit more biologically sound curves to the data to perhaps explore a slightly better quality of fit than hopefully a more interpretable model. And so I'm going to try and demonstrate to you how we can fit this flattened S-shaped type curve to the data. Sometimes it's been called a sigmoidal curve to the data. This work was published by myself and Greg White nearly over 10 years ago in a good journal, but not Nature, Medicine, Science and Sport Exercise. Curiously enough, I did submit this work to Nature, and of course it got rejected. Surprise, surprise. There we go. Okay, that's how it looks in MedSci. So that's how it looks. And I've got some reprints, or I've got some PDFs if anyone wants a copy of it. Okay, so first question, do we do speeds or times? Well, the fact that the linear function of time actually goes negative if you carry on ad infinitum, but I decided to not use times but use speeds to model my data. So that's the idea. Given that future projected world records, such as running times, cannot continue to decline, become negative, we decided to use speeds. So careful inspection of some of the scatter plots does show some indication of a flattened S-shaped type curve. And I'll use this one as an example. This is the men's mile works during the course of the 20th century, going back to the 1900s, coming up to the present day time. You can see there is some evidence of curvature there. Just for those people in the audience, 4-minute miling is at what speed in miles per hour? 4-minute miling? Anyone in the room that's got there? It's 15 miles an hour? Yeah, 15 15 miles an hour would achieve 4-minute miling. And so there you've got your 15-minute mile, sorry, your 15 mile per hour, or your 4-minute mile. And of course, this is the famous Bannister time, which he then suddenly managed to achieve by going a little bit faster and breaking the famous 4-minute mile in 1950, 1953, is it 1953? Do you remember? Okay, so let me superimpose the curve that I'm trying to describe. It doesn't look very dramatic in this particular example. You can see evidence of a here where it starts to become steeper, and it's just tailing off a little bit up here, really. So that's the flat mesh-shaped curve that I'm talking about, that I'm trying to fit. Okay, this is the equation of that line. It looks very complicated, but it's not asymptotic. Yeah, okay, I accept that that probably makes you want to sort of give up and commit suicide straight away. But in fact, it's actually biologically quite sound. It has a minimum. So it says that at some stage, when no one ever did any training or whatever, they had a really low score, and then it goes through an acceleration phase. The rate of acceleration is given by this parameter v, and then it actually peaks off at a maximum, which obviously is where we assume that people, once they've got their training out of the way and they've got all their tricks out of the way, all the nutrition, any improvements in their shoes or the quality of the running track, for instance, and going to tartan, from cinders to tartan, all those things have all happened, and then you should reach a maximum, which is that point there. And there is a point of acceleration, which I've just called y, which is the point at which the maximum acceleration is occurring, the year that the maximum acceleration occurs. This sort of equation that we're talking about. And I fitted this data to quite a few examples. I'm going to demonstrate, first of all, some of the earlier ones. But let's spend just only a brief second to have a quick look on how the fitting of a non-linear equation fits. These are the mile world records. Obviously, the earliest recorded ones, 1913. And it was 4 minutes, 14 seconds at the time. That's the miles per hour, that's the speed, and that's the time. And of course, as you go down here, it breaks the 4-minute mile. Of course, that's the, where's the 4-minute mile broken there. I'm slightly confused that, oh yeah, there we are, it's broken in 1954. So that's when it actually went down through it. There's a few more breaks on the world record down there. How do I fit this regression line through? Well, for anyone that's in the slightest bit interested in fitting the kind of non-linear curve, you have to use this regression line. And there's a non-linear option down here. And I've done it already, so this is the speed that I want to use in the column of speed, and I've got the minimum and the maximum equation, etc. here with the y and the beta weight there, and you have to put starting parameters. So you have to guess what the starting parameters are. So 4 miles per hour is the slowest, 9 miles an hour is the fastest that they've achieved. A rate of increase of 0.2, that's arbitrary units. But the centering of that 1950, I don't know exactly where it's going to occur. And if you now click OK, it whacks through a lot of iterations very quickly. So it does iterations, it's done over 9 iterations, where it calculates and then recalculates, and it changes all those parameters. So there's my starting parameters, and then it modifies them. So the maximum goes from, on the first iteration, goes from 4 to 14. The minimum goes from 4 to 14, and the maximum goes from 9 to 15. But it keeps on adjusting, and slowly iterates to a final solution down here, which is the point at which it reaches the errors are getting smaller and smaller, and it has that centre point of about 1955. The parameters then are displayed in this output here, and you can see that the estimate and the standard error are always twice the size of the standard error, saying that all the predictions are highly significant, which is quite nice. So that's how the software fits those rather complicated equations. It does it very quickly, and it's surprising how robust it is. I use that same equation with almost the same starting points on almost every world record set of data that I had, and it always seemed to home in on the optimal solution very quickly. It was remarkable how robust the model was. So let's go back to some results. So here we are. This is the 800 metres for both men and women. You can see it is coming up to more like present time. And you can see the flat mesh-shaped curve in both the men's speeds and the women's speeds looks fairly convincing. Well, I hope you're convinced at least. Here's the 1500 metres. So the curve here. What do you notice about the women's scores here? Well, women were not allowed to compete at 1500 metres. They thought it was too far for them to run. So women had to be protected from such an arduous task of running all of 1500 metres. And so they only started in 60. So I think that was the Rome Olympics, 1960. No, Rome Olympics wasn't 1960. It must have been the Tokyo Olympics, 1964. So that's when they were allowed to start competing. These are the actual parameters that I fitted, just for interest. You'll notice that the women's beta weight, which is given here and here, are much higher than the men's beta weights, indicating that there is a much steeper rate of decline, and also that the centred point for men was 1952 for the 1500 metres and 1946 for the men's 800, but much, much later for the women, 1950, nearly 1960 for the centre point there, and 1971 for the centre point there. So a shift for the centre point to the right for the women's schools. These are the men's mile, 5,000, 10,000 marathon results. I think they look fair. Well, certainly I would argue that the curves look more feasible than the Whipham Ward's linear lines through. That would be my strongest argument to the audience tonight. And those are the fitted parameters. I won't dwell on them too long. Okay, I wanted to compare the quality of fit, and there are several ways in which you can do it. Comparing the adjusted R squared would be one way, but in all cases, the R squared of the 4 logistic parameters compared to the 2 logistic parameters, they were always superior. So we always had a better quality of fit, whether I'm using the adjusted R squared or using this trick I used, which is the addition of the 2 parameters and the significance gain. So just to summarise, this is a summary of the world records at the time. Here's my predicted time and speeds, and these are the actual present times and speeds. And in all cases, the predicted times are always faster than the actual ones. The only exception, actually, is the women's 1500 metres, where the current record holder, Kwa Young Shan, is that correct? She has already beaten my prediction equation, so you can't get it right all the time. Further evidence, since I wrote the paper, this is in addition to the work I presented in the paper with Greg White. These are the 5,000 metres for men and women. And you can see there's such little. The reason I didn't publish the results of the women's 1500, there was only about 11 world records that I had. So with such limited data, I couldn't even fitting the sigmoid curve did a really good job, because it's obviously got that rapid rise, the acceleration period, and then the sort of beginning to plateau area for that. So that's for the 5,000 metres, which is fairly encouraging for me. And that's for the 10,000 problem, just such limited data, but this rapid acceleration for the women's scores, whereas a much slower for the men's. And that's the marathon for the women's as well. This was interesting to me. I took the data off the internet. The 20,000 walking speed world records. It is still an Olympic event, so I thought I'd take those off the internet. And you can see I'm not quite sure what was happening here, but the model does fit quite well, apart from those really strange outliers. Okay, so my conclusion, having asked for a straw poll at the beginning of the talk, where I had 2 or 3 people with their hands up for both options, clearly these linear models which say there's no limit to how well we perform is highly questionable. I would argue that you really must be very not giving it your full consideration to consider that a linear model is correct, that these biologically sound flattened esoteric curves are more likely to be better than the 2-parameter linear models. So I think everyone, I hope, has been convinced by my comments previously. So we've definitely got evidence that there is an asymptotic limit. The word asymptotic means that it's reaching that plateau. Okay? Asymptote, it's actually reaching some upper limit that we can aspire to. The greatest periods of acceleration for men was occurring in the sort of midpoint of the 20th century, between 1940 and 1960. So that's a period of time when, a bit like Bannister, they were starting to learn new training methods. They were using interval training. They were probably nutrition was improving. All those things were giving them the edge for the acceleration for men's more rapid acceleration at the midpoint of the 20th century. But what's happened for women? This is the women's data. Warrants a little bit more caution when you start to look at the women's results. The greatest period of acceleration occurs much later, in the early 1970s, perhaps, and even perhaps later. And a good example of this actually are where new events, women's pole vault is only a relatively new event, and you've got this rapid acceleration period where the world record for the pole vault was broken 9 times in 2004 and 5 times in 2005, etc., etc. Well, it's going through that rapid acceleration because women hadn't really competed at the pole vault before these times. And what I think you're seeing in the Paralympics at the moment in Rio is evidence that these world records for the Paralympic performers are going through this acceleration period right now. And so we're getting these world records being broken quite frequently, which I suspect that as events, as the dust settles, we'll start to see them plateauing perhaps in 20, 30, 40 years' time. So that's what I believe is happening. Okay, we could forgive previous authors for assuming that the world records were converging and that women were going to overtake men's running speeds. If you can imagine, obviously, the line through this, the line through this, you can see where Whitman and Ward were extrapolating, but of course they made the fundamental mistake of fitting the wrong model. And by fitting more realistic models, we're going to get much more sensible asymptotic limits to all these performances. I've just got 2 or 3 more slides to show you now. I just want to talk about perhaps how the gap between men and women has changed over the past 50 or 60 years. And I'm referencing a colleague of mine at Birmingham University, John Furlong, that wrote a paper that was quite a seminal paper in the Statistician, which is the Journal of the Royal Society's one of its prestige outlets. And what he thought he would do is actually plot the ratio between the women's performances and the men's performances, and see how that ratio is narrowing over the course of the second part of the 2nd century. So he defined the ratio as being the women's performances divided by the men's performances. At the top 20 performances in each of the current years. So he looked at the top 20 performances of the men, the top 20 performances of the men and the top 20 performances of the women, and calculated this ratio for this entire duration here. Here comes the ratio. In 1950 or 1951, the ratios were on average about 0.8, mean average about 0.806. And by 1967, the averages start to creep up to about 0.83, so it increased by about 3%. So the increased percentage on the right-hand side. So what I thought I would do is look at something similar, using a similar ratio, same idea, women's world record speed divided by the men's world record speed, and plot it from 1951 onwards. And this is the results I got. First of all, for the 1951, 1967, which is the Furlong article, then the ratio in 81, and of course the ratio more recently. And you can see that the ratio is steadily coming up from 0.75, 0.78, 0.87, and it's getting close to, it's starting to plateau out, and it looks like the ratio is tending towards about just under 0.9. So we're talking about the asymptotic ratios all quite close to or reaching about 0.9. So the gaps are going from 0.7, 0.7 bits up to 0.8, and now it's reaching 0.9. So just to conclude, I think everyone in the room hopefully has been convinced that there is sufficient evidence to say that world records are actually tending towards realistic asymptotes, realistic plateaus, shall we say, and that it's a non-linear trend, not this linear trend proposed by Whitman and Ward. And the gap between men and women's world records is narrowing from about 0.7 up to about 0.9, or 90% of the men's world record speeds. And finally, given the predicted asymptotes, it's very unlikely that women and female athletes would ever run middle and long distances faster than men. That's it. Thanks very much indeed for listening. Questions?
2-hour marathon, Alan.
Yeah.
For me.
Yeah, I think it'd be broken.
Okay.
Yeah. Men, yeah. I think what will happen is you get the ideal conditions in the ideal, the ideal temperatures, the ideal training, and someone will have a really purple day, purple patch, and they will break it. Yeah, I think so. All these world records are breakable, but they're going to become less and less frequent. So that it's a bit like a normal curve. It's going to get closer and closer. But when you get the absolute perfect optimal conditions, it might just edge to another world record. The gaps to the asymptotes are going to get smaller and smaller. So that's the way I imagine it's developing. The only time that things will actually become dramatically improved is when someone breaks a new technique. And a classic example is the Fosbury flop. You remember when the straddle was being used to, some of you won't remember, but they used different techniques for high jump, and then suddenly Dick Fosbury did the Fosbury flop, and then suddenly the world record jumped by about 8 or 9 centimetres, and so you do get the sudden change, and if something momentous like that happens, then we will get another change in events. But most of the running events don't require equipment. So yes, they will break if you've got some dramatic new change. A good example, they used to use wooden poles in the 50s. They went to metal poles in the 60s, and then the fiberglass poles in the 70s. And how the world records then suddenly changed, of course, was because of the equipment, the technical equipment. But I think these world records in the Paralympics are going through this acceleration phase, so I suspect that world records are going to be broken in the Paralympics fairly frequently, which may appear to contradict what I'm saying, but that's because it's going through this acceleration phase.
Here's a relevant question till today, given the controversy over drugs, is that, and in the Olympics, the 10,000 metre female event was won by a country mile by one woman. Would it be possible to identify a performance which is beyond the expected improvement, and therefore, in other words, based on the statistical evidence, somebody making this leap, well, how likely is that based on the thousands of bits of data that go up to the existing relationship?
A good example of that, Andy, is Flojo. Do you remember Flojo in the Seoul Olympics? And her world record has never been, no one's ever got anything near it. And you could probably statistically show that's an outlier by doing some kind of a normal probability plot. You could do. But then it's only subjective. I don't think you can objectively prove that an event was an outlier. You can only say that it's unlikely with a certain degree of confidence intervals. That in fact it actually was sufficiently outside of the normal range for it to be considered as an outlier. But I don't really think it's proof. It's not proof. It's just strong evidence.
It was the way of being a bit more scientific and looking to see the extent to which records are creeping forwards, for even leaping forwards. And we can all see them leaping forwards, and particularly that 10,000 metres in the Olympics. It's like jaws were dropping as Liz Pavey got lapped.
400 metres men's 400 metres was broken for the first time. Your good friend Michael Johnson, and his jaw, did you see his jaw drop?
No, when
it broke, he was so upset. But I thought he was an excellent commentator. But you could see how disappointed he was when that 400 metre run broke it. It was quite amusing.
Do you not think because obviously the previous Olympics just gone, there was all that about the South African female athlete, about whether she should be allowed to compete because there was the things about her gender. Do you not think that, well, because she was allowed to compete, in the future, if that carries on happening, do you not think that female athletes can get to men's level?
Well, the only way I think that the women will get closer than this 90%, I think, is if they have something like gene. What's the word when you manipulate genes? Gene doping or something. Yeah. That's probably the only way I think that could actually happen, because naturally occurring. I mean, men have the testosterone. progesterone and the women have the estrogen. And, you know, these hormones, you can't muck around with them too much. If you do, you will get some strange outcomes like the South African athlete.
Okay.
I think that the human being is outstanding. We've evolved, and we're an outstanding demonstration of the survival of the fittest, Charles Darwin. And I really don't think we should start mucking around with anything that's going to.
I'll put that idea to the
Forget that idea. I think that let's be quite honest, the drugs, well, Flojo is a wonderful example. What age did she die? She died at about 38.
Yeah.
She was
Was she
38.
that young? I thought she was older than that. Never. Okay.
She died very young. I just have it on the top of my head. But she died, and why did she? Is it worth it? You have to ask yourself, don't you? Is athletics, having success in athletics, so important that they die young? Because that's kind of, if you go along with that line of doping, then that's the decision you're making, I think. So, you know, are you prepared to sacrifice longevity to have a few seconds of being famous?
So, do you know stuff about the Paralympics? Do you think they're improving based on the technology for prosthetics and stuff? Obviously, we're improving.
Yeah.
So,
You wonder whether people that wear the blades, for instance, have because didn't the South African Pistorius, didn't he run in the regular Olympic?
Do you think there'll be a point
So I think
pass?
there could be a time when that kind of innovation, like the pole vault, you change the material that you're using. If we were able to change the material that the blades are made out of, it's quite possible that it's quite possible. So we're talking there about the innovation rather than the evolution of world records. And that's quite an important distinction. The innovation is when you have a technical breakthrough that gives you an added change in world record performance, whereas the evolution is what I've been talking about today. And that's why I've spent most of my time talking about athletic long-distance world running performances, because that's the evolution. It's not a revolution. You know, it's not a sudden breakthrough which is caused by a technical breakthrough. It's just the development over time.
on that subject, would you say the limitation of how fast the human can run at some point?
That's I think what the whole talk is about. Really.
Yeah.
And I obviously feel that yes, that is the case, unless we start to do some doping. Jesus. See? Anyway, any more questions?
Do you think it'll be the same across other sports like swimming as well?
Yeah, I looked at swimming and the instruction about those new suits.
Yeah, it's the reducing suits.
That's the breakthrough, the evolution rather than the that's the innovation rather than the evolution process. And when they were banned, of course, world records for a short period of time weren't broken so frequently. But people are still going through the acceleration phase in swimming, which they're not doing in middle and long distance running. So I think that's partly because they are evolving, but they're going still through a slightly steeper point of the acceleration period.
So, do you think that it's down to? I know you already said that it's most likely because of the advances in training and nutrition. Did you not think that it could as well, I don't know, be linked to human evolution still maybe? Did you not think that a potential, look how fast
I mean, people choosing their partners is almost certainly going to, when you've got two Olympians getting married, is it so unlikely that you're going to have the right sort of genes to So you are getting these evolutions where the human is choosing very carefully their mum and dad. So I mean, is it Laura Trott and Jason Kenny getting married, aren't they? I imagine their little kids will be riding around on bicycles so fast. I mean, that's a good example of where two people with the right genes are probably going to give themselves, with their offspring, a real extra bonus chance.
Some of that's going to be nurture as well, isn't it?
Oh yeah. I mean, you can't do anything without nurture. But you're right to say that they will be, because their expectation will be to perform well, and they're going to have all the right opportunities. Haven't they? That's right. So, what age do you start playing tennis? You've got Agassi married Steffi Graf. What age do you start them at to show that their kids playing tennis? They've got that. They must have a massive advantage of being Grand Slam champions. They've got two kids coming from mum and dad like that. Definitely got an advantage. So we're wrong with my wife. And she's an Olympian, and our kids are useless. Not true. Tom's quite good. They're both average. They're good average.
Would you say, like, 'cause obviously nowadays